So tell me. Oh, let me make sure I have volume on. What's the only country in the world that is stupid and does not use the metric system?
The only country in the world that does not use the metric system.
The only stupid country.
The one we're in.
What?
The one we're in.
Yes.
What is it? What is that?
He said the one we're in.
The one we're in. We are the only country that doesn't use the metric system as their official form of measurement. Think of any other country in the world, they use the metric system. We don't, which is stupid. Because, let me just give you an example. How many inches in a foot? 12 inches. Very good. Okay. How many inches in a yard?
36.
36. Very good. How many feet in a yard? No. Not.
Feet.
Uh,
I'm sorry.
6.
no.
3?
3. Because there's 36 inches and
Yeah.
a foot is 12, so 36 divided by 3, or 36 divided by 12 would be 3. Okay, now for a tough one. How many feet in a mile?
It's like 3,000 something.
More.
How many feet are
Feet? I don't know.
5,280. How many yards in a mile?
I'm saying 100.
Uh-huh.
100 yards? Is that
Nope.
right? I think it's gonna be more than
1,760.
that. Yeah.
Now for the good one. How many inches in a mile?
Hundreds of thousands.
62,500. How do I know that? I had to memorize it. Because those numbers, I say 62,500 equals 5,280, which equals 1,760 equals 1. That's jacked up, is it not? That's jacked. How many teaspoons in a tablespoon? I don't know. I didn't memorize it. How many tablespoons in a quart? Or a pint? I don't know. I didn't memorize it. I have to look at a cookbook to figure it out or look it up online. How many ounces in a pound?
16.
16. Okay. So 16 ounces in a pound. How many fluid ounces in a pound?
8 ounces. No. How many fluid ounces is in a pound?
Mm-hmm.
Would it be 16 still?
No, there's no correlation between the two.
Yes.
Because fluid ounces measures volume.
Yes.
Ounces.
Okay. Yeah.
And then, what's the difference between a nautical mile and a land mile?
I've never even heard of it.
Nautical mile is like
Is it going up?
ravine or whatever. I'm thinking.
It's-
Is it like
It's distance
pressure
over
or whatever?
water, which is
Oh, okay.
a nautical mile is different from a mile. I don't know what it is offhand because I didn't memorize it.
So in science, we have to do lots of measuring of different things. Think of what are some items that we have to measure. And you said, I heard you say volume, right? How much is in something, right? So that's one thing you have to measure. What's another thing you have to measure? Okay, length or distance. We have to measure length and distance. Okay.
Area. Area.
Area.
Mm-hmm.
Well, time. Okay. That's pretty standard though. Cross-set radius still uses minutes, seconds, and hours. Let's see, which ones am I forgetting? Oh. Okay.
Heat.
the in the elements? Or, I don't know where you're at. I'm sorry.
How about temperature?
Temperature?
Temperature.
Okay, yeah. Temperature.
Temperature.
Like what?
Another thing is, what's the temperature of boiling water? It's 212 degrees Fahrenheit.
I should know that.
What's the freezing temperature of water?
Negative
32.
It's 32.
32.
Isn't that weird that 32 degrees is the freezing point of water? But a guy by the name of Fahrenheit, that's what he came up with. It's jacked up. How did we figure out how long a foot was originally? Over in England, how did we know how big a foot was?
Obviously, that name had to come from something, right? Somebody's foot.
Somebody had a big one.
Somebody's foot. Who do you think is the most important foot in the whole kingdom?
The king.
The king.
King of England.
Yep, the king.
I didn't know
And
that.
therefore, you wanted to buy property when you had a big-footed king, and then sell when you had a small-footed king.
Okay.
Think of that, could be a nice racket.
Wow.
That's where that came from, for real?
Yeah, I mean,
Yeah,
they
I know that.
originally that's what it was, and so measurements changed, and they finally realized that was horrible,
Yeah.
and they then settled on an exact foot, and actually in a museum in England somewhere, there's a brick of lead that is exactly a foot in length, and that's became the standard, was that block of lead that was exactly today's term of foot.
I did not know that. Wow.
So the measurements that we use here in the United States is often called standard units, or it's the standard unit of measurement, where all the rest of the world, they use what are the metric units of measurement. Okay. Sorry, said we're going to discover here today how easy it is to find out or convert from a unit of measurement in the metric system compared to what we were just discussing with different units of measurement in standard units.
Yeah, standard units, we have inches, feet, yards, miles, ounces, pounds, half ton, ton, nautical mile, teaspoons, tablespoons, pints, quarts, gallons. That's a whole lot of stuff to know.
That was the other thing that we didn't have listed on our measurements, weight. We have to measure weight, right? So as scientists, they need to do this on a daily basis and be able to do it very quickly. So as we discovered today and we're learning how to use the metric system, think about how long it would take you just to go from different types of measurement and then understand why do we use the metric system in science. It'll make sense to you as we're going over this today.
Yeah. You only need to know 9 words to understand the metric system. 9 words. Ready to write it down?
So the blank sheet on this,
There's some paper down there.
okay.
9 words to know the metric system. Only 9 words. And you can measure in length, volume, or mass by knowing these 9 words. So you ready? Kilo, deca, milliliter, and consistent milla. Got it?
Crazy like that. No.
Kilo, deca, milliliter, gram, consistent milla.
Okay, Greg, come on, spare them for a minute.
Ah, okay.
Draw a stair step on your paper. And you put these letters above each step. Just so you see here, and we'll go over what each one of those letters means.
So,
Is the third one a D? That's a D.
Mm-hmm. Oh, and it does matter your capital and lowercase letters, by the way.
It does
Capital,
matter.
capital, capital, and everything else lower.
mm-hmm.
So if we put on the test and we do it wrong, would it be counted wrong?
We'll explain why it's capital and lowercase.
And it is important.
Yeah, it is. Did you notice that some of those letters are the same letters? Yeah. So it does matter because a lowercase means something different. if I said some of these letters represent large measurements, which do you think those would be? Your capital letters or your lowercase letters?
Capital.
Yeah, large letters, capital letters.
Mm-hmm.
Small measurements are your lowercase measurements.
Yeah.
And we have this written in a staircase. If you know that we have a staircase and all of a sudden we switch to capital letters, are we as we go from left to right, are we increasing or decreasing our units of measure? Yeah, decreasing. We're getting smaller. We're breaking it up into smaller and smaller and smaller pieces.
Mm-hmm. So back to those 9 words. Kila tak miliran just as Tamila.
Let's write them out for them.
You got it right?
He's just being silly.
I don't ever expect you to be that good. Kilo.
Now, some people around Anderson know this one by heart.
And we're not talking about the white powdery stuff that you go,
Oh my gosh.
or you cook the white powdery stuff, then go, no.
So, if you're high as a kite, which step on the staircase you're going to be at to help you remember the highest step? The highest stair is your kilo.
And then next comes hecto. If you guys if you can't ever read my writing, I don't have a problem with you calling me out, because I'm left-handed and they tried to teach me to write like this.
On top of that, the stylus on these things are, I don't even care if you have the best handwriting, it is hard to write on a stylus on those.
All right, so if you can't read a letter or anything, I don't have a problem with you calling me out, because sometimes I'll make a mistake on purpose so that you have to find it and correct me, because that's a good way of learning. If I do something and purposely put a mistake in there, you need to be able to understand the concept, be able to catch me with that mistake. Sometimes I just mess up, but a lot of times I do it on purpose. And you always know that when I go, is this correct? Are you sure? Are you really, really, really sure? Then it means there's a mistake in there that you got to find.
Okay, so you've all heard probably at some point or another someone talk about a kilo. But most of us haven't ever used a hecto.
I did.
What do you use for a hecto?
Hectacre?
A hectoacre? A hectoacre? They had it measured in hectoacres?
Yes.
That's new.
In Oklahoma and Kansas,
Oh, okay.
farms are measured out by hectoacres.
Really? Hectoacre.
I know they have squares and they do these things.
Yeah. You can go down any road and it's going to either go north and south or east and west, because it's been gridded out like a math grid.
Yeah.
But here, I was really baffled when I moved here, because all the county roads were paved. In Oklahoma, they're just dirt and gravel. And
then
coming
you come
here,
we have cul-de-sacs. We like to make the craziest neighborhoods ever.
yeah. Okay, and then next comes deca. And then the next line, you notice there's 3 letters there, right? That's because those are all the base units for length, mass, and volume. What is the unit that we measure in the metric system for length?
Miles. No.
Nope, that's our system measurement.
What's the what? Can you repeat that one here?
He said miles.
Oh.
No, we don't measure miles in the metric system.
So miles is standard unit. The equivalent to a mile is not the actual same
It's actually
distance.
0.6 miles in
Yeah.
length.
Is the... How about this? If I say in standard units you have a yardstick, but in the metric system, what do we use? They look very similar to one another.
This is what we're talking about.
Cubic feet.
That
Starts with the letter M.
That is a meter, or that is a yard. This is a
You said it already.
Starts with M.
Meter.
Yeah. It's a meter. Yeah.
It's a meter.
Okay.
So in the
This
so you've
is
got-
a meter stick.
A meter set, so that's about, okay.
So if you're measuring length in the metric system, you're measuring meters.
And
Uh-huh.
you're measuring length.
If you're measuring length, you're measuring
Uh-huh.
meters. So you might want to write next to meter, put length.
What do we measure in volume? What are the volume measurements of your drink
Ounces.
in metric? Ounces is standard.
Pint. Oh, start with.
Think of your pop bottle.
A big bottle. What's those big bottles that you buy of pop?
It's two of
It's a
something.
liter.
A
Yes. Liter.
liter.
And that measures volume. It's a capital L because if it was lowercase l, what did I just write right there?
11.
No, that's one L.
You have two lines there.
Yeah.
Okay.
Because people don't write clearly, they could say that that's that. Capital L, there's no confusing a capital L from a 1. You also will, that is the official way, you also will see lowercase cursive l, but officially it is capital L. But if you see lowercase l with just the line, that's still okay, but it can cause problems, or lowercase cursive l.
Shake your mouse.
Now for mass.
Would that be gallon or would it be
Nope, it does start with the G.
grams?
Yes.
What did you say?
Gram.
Gram. Again.
Grams. Oh, I thought it said grams. I was like,
No.
Again,
Okay.
people in certain parts of the neighborhood know this measurement really well.
Yeah, that's for Mary Jane. Grams are Mary Jane-ish.
Maybe in square brackets next to length, volume, and mass, let's write down what they are in standard units, just so they have
I'll do
something
that
to
on the
relate
next-
it to. Or you
I'll
do it
put on the next slide.
Okay.
Because I still have to do the arrows that I put up there.
So how much is a gram?
1 cubic centimeter of water.
Okay.
That's what's cool about the metric system.
The gram is?
A gram is a cubic centimeter of water, which is 1 milliliter of water. Isn't that cool? 1 cubic centimeter of water is 1 milliliter of water, which weighs 1 gram.
1 milliliter, right?
Yes. And that's only true for water.
One in water.
Then the lowercase d is deci. Oop. Need more room. And that is a lowercase d, so you can distinguish it from deca. Then we go to centi.
Exactly.
Mm-hmm.
Exactly. That's what
There's
that is.
100 centimeters in this. And what would be the last one? Anybody know?
Mile.
Hmm?
Mile.
No, it starts with an M. Think of a...
So mile is standard.
Oh.
These are all the metric
Millimeter.
measurements. So miles is not a metric.
Meter. No.
milli,
Milliliter.
B.
milliliter, because this is 591 milliliters, which means that's slightly more than a half liter.
So depending on what you're measuring, if you're measuring length, volume, or mass, these these are your base units, or types of things that you measure. So either meter, liter, grams. If you go bigger, like a big thing, then you would call it a, let's say we're measuring length. The base unit is meter. If we get bigger, it's called a decameter. Getting bigger would be called a hectometer, and then kilometer. If we're going to get smaller, then it would be a decimeter, centimeter, millimeter.
And
So units of measurements is made up of two parts, a prefix and like a root word. The root word is meter, liter, or grams. Your prefix tells you how big or small that you're measuring.
right. And you see, I put a 1 underneath meter, liter, and grams because that is the base unit of 1. What do you think deca means?
Double.
Have you ever heard a word that starts with deca? A deck.
The deck of cards.
A
No.
deck of cards. How about time? Think of time. Ever heard of a
2010, 2020.
A decade.
A decade.
A decade.
Yeah.
How many years in a decade? 10.
10.
Okay, okay.
So that's where deca comes from.
Right.
Like a decade.
Hecto. What do you think hecto means? Yes. Very good. And what's kilo mean? 1,000.
So the metric system is all base 10. You just add another 0. If you're going to get bigger, you add another 0.
All right. And then going to deci, what's that little coin, the smallest coin that has Kennedy on it, and it's really small, and it's shiny, silvery, what?
The dime.
A dime.
Dime.
Deci, dime. How many dimes does it take to make a solid dollar? 10.
So,
So-
how much is a dime worth?
It's worth point.
0.10. 10
point one
cents.
cent, yeah, it's worth
0.1 or 1 over 10.
So 10 cents.
Centi.
So this 0.1.
Uh-huh. Centi. What's those things that cost 2.7 times the amount it's worth that we get, and a lot of people don't keep it and put it in a little cup next to the register?
Oh, pennies.
Pennies. What's another name for penny? Cents. Centi, cents. How many cents make a solid dollar?
100.
100. So it's 0.01, which is 1 over 100. And then milli,
Maybe 0.1000.
1,000. So it'd be 0.001 or 1 over 1,000.
You can always remember these as you get smaller with units of time. Like we had a decade. Think of a century is 100 years, and then a millennium.
Yeah.
Okay? So if you can have those to remember, it's just the zeros come before the 1. And you have a decimal because it's small, like money, less than $1.
Mm-hmm. So you can see that it's all based on the powers of 10. Every time we go up or down a step, all we're doing is moving the decimal place. That makes it so much easier.
So it's
Because your numbers that you use, they're not going to change. The only thing you have to do is move the decimal
So it's 0.01.
for centi. And so therefore, can you see those purple lines that I have up there? The one at the top is going down the staircase, right? What direction is it also traveling besides going down the staircase?
What direction?
It doesn't matter what direction. I could put that on any wall.
Right.
To the right. Guess what you do with the decimal when you go down the stairs? You move decimal to the right. I'm butchered decimal there.
Just to help you remember. You don't want this, right? You don't want that. No, nobody wants that. Let's go the right way. My little analogy to help you remember. Yeah, we don't want to be high. Let's go to the right way.
And then, so if you're going up the staircase, what direction you're going?
To the left.
To the left. So you move the decimal
Okay.
to the left. That's the metric system.
So if you're getting higher, you're getting loaded. Loaded starts with L.
So now you understand kilogram, decameter, gram, deciliter, milli. I just like doing it that way because it catches people's attention. I don't ever expect you to be able to say it that fast. And that's about the only thing I can really rap real fast. So I'm proud
we
of
will
myself.
expect you to be able to list the units of measurement in order from highest to lowest on a test, and we're going to be converting them today.
Mm-hmm.
That's one of our objectives.
Okay. So notice it's all based on the powers of 10. If I'm going from deci to deca, how many steps do I take on my metric staircase?
Up one.
So say that again, and I'll be Vanna here. Where are we starting, Craig?
Just on.
Deci.
Starting here.
Oh,
So you always ask, where am I now?
And where did I say we were going to end up on?
Where do I want to go to?
To Deca.
To De- Oops.
She did it. We're going to
Go up
So it's gonna be 2 steps.
2 steps. 1, 2.
there.
Okay. So here's where I started. Where am I going?
Deca.
Up here.
So 2.
How many steps do you need to take?
2.
2.
1, 2, and in what direction?
Left.
Or to the left. Yeah,
To the left.
So when we say direction, I want to say left or right,
Okay.
because that's what you're going to be doing with your decimal. So let's write these questions down. First question that you're always going to ask here: where am I starting? Where am I starting? Two, where am I going?
It's like a modified Where's Waldo?
Yeah. That's where I'm starting. Where am I going? What direction? We could combine that 1 and 2. In what direction am I going? Yeah. And the fourth one?
I could say 3.
How many steps?
Yeah, you lied.
What?
You said 3 steps.
Oh, I'm sorry.
So I
Well,
don't.
step 2 and 3 must be combined together, but how many?
What was the 4th
How
one?
many to get there?
How many steps?
How many steps? One thing I do want to cover is, were there any conflicts with letters up there on your chart?
Is there any conflicts with letters?
Yes. Is there a conflict of abbreviations? Is there more than one capital K?
Nope.
Capital H?
No.
D? There is a conflict because there's 2 D's, but one's uppercase, one's lowercase. The bigger unit is uppercase because it's the big dog, and the little d is a little dog because it's a smaller unit. Then, are there more than one L? No.
No.
More than one G?
No.
We already did the D. What about the C? But the M. The M, both meter and milli are lowercase. So there's a rule that you need to know. If M is the first of two, it's milli. If M is the second or only letter, it's meter. If M is the first of two, it's milli, always. If M is the second of two letters or by itself, it is meter. So if I have a mg, you know it has to be milligram because there's no such thing as a metergram. It's cool to say metergram because it just rolls off your tongue. Metergram, metergram, metergram. Say that 10 times fast. It's a tongue twister, but it's cool. But there's no such thing as a metergram. So meter, meter, metergram, 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 metergram is not real. It's fictional.
Let's do a quick check for understanding. Just write down a few abbreviations and see if they can read them off. Write down several of them.
Do we need to write them down, or are we just going to do them in here? Do we need to write these down, or are we just going to...
This is just practice to make sure you understand. Do you get what he had up there already? Okay.
See?
Don't get it, but I got it down.
You don't.
We're
Okay.
going to work on that.
Let's do it. I'm sorry, and I've already forgotten your name.
That's okay, Julie.
Julie.
Julie. Julie, can you take the cm and tell us what cm would stand for then?
Is it centimeter?
Centimeter. Does that make sense to you now?
That, I mean, yeah, that's easy.
Okay.
I mean, this, but
Can
that
you do
don't
the
make
next
sense.
one?
It's possible.
You will. Break it down. What's H?
I don't want to say HL.
No. It's
H.
HL, but what's the H stand for?
Oh, is it hecto?
Hecto.
Liter?
What's the L? Uh-huh.
There you go. So it's a
Hectoliter.
I didn't know there's such thing.
Okay. Give me a number between 1 and 10.
6.
Okay, you're closest. Do you want to do the first letter or the second letter?
I'll do it first.
Okay, what's the first?
Kilo.
What's the second one? Gram. Don't go tell your buddies I'm teaching you drug terms, because that's scientific terms. Okay. What's that?
Milliliter. I mean meter. Milli something.
Say that real loud so I can hear you.
Is it millimeter?
Yes.
Millimeter.
Because there's no such thing as meter.
I mean, I know these abbreviations. It's this little thing right here.
So what he's saying is show him with the M. So what's this one?
It's this meter.
That's just meter. That's what that's saying right there. It's just saying
What's
if
that?
you see
It's milligram.
milligram, yeah. It's not a metergram, right? It's a milligram. So that's what that's saying right there.
What's that?
Okay. Kilometer.
Good.
Hectometer.
What's that one? Julie? The-
Decimeter?
Mm-hmm. No.
No.
Take a look at it again.
Oh, wait a minute.
This is one that could trick you, and don't fall into that trap. Look
Yeah,
in there
I
and
do.
see if you can correct her.
Decameter.
What is that?
Say it, tell her what it is.
Decameter.
How do you know it's decameter?
It's a capital D.
Because it's a capital D. Very good.
Decimeter.
So do you think we'll probably put a decimeter and a decameter on your quiz, on your test? Oh yeah, you can pretty much guarantee that one.
What's that?
Do you know it? You whisper to me. Centimeter, did you know it before you heard it?
Oh, she
Yeah,
heard me.
okay, yeah, it's a
Okay,
centimeter.
let's play a game. I'm going to put one up there and see who can answer it correctly first. You ready? No, I won't do that one yet. I had a couple of dirty ones.
Decimeter.
Nope.
Oh, that's just a G.
Decigram?
Yes.
There you go, 1 point here.
Ding,
Here, I'll keep score here.
It's really called
Wait.
decigram?
It's called a decigram,
Okay.
because you're measuring mass,
Uh-huh.
volume.
Hectoliter.
All right, 1 point over here, hectoliter.
Um,
So you don't have to write these down, we're just practicing.
Oh, okay.
yeah.
Milliliter.
All right.
See, yeah. Oops.
That's all right, I got my fingers up, so you're fine.
Kiloliters.
Woohoo!
I couldn't see what you wrote down.
Excuses. Um,
It's not a liter. So.
So that's where he said he likes to mess with this sometimes. So you're supposed to say that's not a measurement.
that's not a measurement. And you
Yeah.
said it, so.
There you go, I'll give you the point.
Okay. Awesome.
She gave the look like, what the? Okay.
And it's good that he's training you for this because I have this like nasty habit of what comes out of my mouth and what my hand puts down on the paper. It seems to be two different things. I'm like I can't get them to sync sometimes.
It went off.
Oh, here we go. Wiggle them out.
Okay.
I'm gonna have to put a mouse jiggler in your computer for you. Let's see.
Cine. That's not one either. That's not.
It's not one either, is it? No?
It is, but it isn't.
It is,
Yeah.
but it's not?
It's not one that's on your list right here. So this is
Okay.
what you would like to tell everybody what this is. So look at the picture that he's drawing.
It's a cube.
Cube or box?
So
Oh, cubic centimeter.
cubic centimeter.
Uh,
Have you ever heard of a CC before? That
Yeah,
measurement?
I mean, when you go to the
I've heard
hospital,
of
You
it.
go to the hospital and say
like
40
that,
cc's and stuff like that.
yeah.
So yeah, this is a measurement you will often hear or use in medical fields.
We need to write that down too.
That's cubic centimeter. Yeah, let's go and write
Yeah.
that one down.
So 1 cc is equal to 1 milliliter because 1 cubic centimeter is 1 milliliter. And with water, it also weighs 1 gram.
So these are our basic 3 units of measurements.
And they're interchangeable, not like fluid ounces and ounces.
Right.
So we can change we know in standard we can't change a mile into gallons.
Right.
I mean,
Yeah.
how do you change a mile into a gallon? In the metric system, we can convert volume, would be like your gallons in a way instead of liters, into distance, cubic centimeters. It's an actual distance. We can even convert it into a mass, or like a weight, a gram. So in the metric system, we can go back and forth.
Yeah, and even though the 1 gram rule is only for water, but if we know the density of the object, we can figure out its mass based on its volume. But that's a whole lot higher math.
Yeah, that's
But-
geometry.
Yeah.
That's geometry.
So let's make sure we can list this. What are some advantages that we've already discovered by using the metric system?
Seems to be a little.
Let's break this down. What are the advantages of using the metric system?
So you see why I said that we were the only stupid country? Because here in the United States, we have to have two different sets of measurements in our factories. Everywhere else in the world, they don't give a crap about the standard units, and they do metric exclusively. Why haven't we switched?
Really?
It's going to cost so much money for these factories to retool all of their equipment to metric system.
We'd have to change all of our cars, our speedometers.
That's true.
I mean, we see kilometers already on there, but it's the little dial.
Yeah.
We would want to make it big. Think of all of our signs. Just in saying, oh, we're 2 miles away, some things we'd have to change it to meters, kilometers, whatever.
And it's easier, and women will love it, because what are women always complaining about? Themselves.
You do not need to write. I was trying to get the real advantages, not our.
Women love it
Money?
because you appear to weigh less.
Oh, yeah.
Because
Small.
if I weigh,
It's true.
there are 2.2 pounds per kilogram. So your weight is less than half. So if you weigh 200 pounds, you weigh like 90 kilograms. Doesn't that sound better? I weigh 90. You don't have to say kilograms.
Okay, so why is this easier? So our advantages of using the metric system. One is that it can convert between different units of measurement.
What else? It's standardized world around, and it's scientifically based. The length of a meter is the amount how far light travels in a given part of a second. I don't remember the exact distance, but light travels at a constant speed of 186,000 miles per second. And a meter is a certain distance, and that can be measured. A foot isn't really well defined. I mean, it is, but it's not as accurate. Everybody in the world uses it, so it doesn't matter if you go from one country to the next. It's going to be the same. And temperature. We said 212 degrees was boiling and 32 was freezing. Guess what it is in the metric system? It's Celsius, because it was developed by a guy named Celsius. Isn't that great? Everything in science, you get to name it after yourself. Guess what the boiling temperature of water is in Celsius?
32.
I don't know.
Okay, so think about this. All the numbers that we've been in is always based in. When we say standardized base thing, it's everything is base 10. We can count to 10. We can add 10. We can switch by 10s real easy. Everybody can count by 10s, right?
Right.
10's an easy number to work with. It's not like it doesn't change. The number doesn't change as we switch to different measurements, right? In metric systems. So that's why it's a great advantage of it. So think of it, base 10s. What would be a number that sounds like it's boiling if it ends in zeros?
100.
100, yeah.
And what would be
100.
the freezing?
Negative 10. I don't know.
0 or 10?
Zero.
Zero.
0.
Yeah.
Freezing point of water is 0 degrees Celsius, and it's 100 boiling water.
Easy numbers to remember because they're all base 10.
Got it. Okay.
And when you do base 10, it makes it easy, because if I have 48.75 centimeters and I want to convert it to meters, I'm going to bring down the numbers. I'm always going to have the same order.
You just gotta move the decimal.
All you got to do is move the decimal. Instead of 62,500 equals 5,280, which equals 1,760. All you do is move the decimal.
You move it to the left, right?
We move it to the left.
So remember those 4 questions, Isaac? What was our first question? Where are we?
Yeah.
Where are we?
Starting?
You move
Where
the
are we
decimal
starting?
one.
We're starting with, the centimeters.
Centimeters.
Yeah.
So we're starting here.
Starting with bottom.
Our next question. Where are we going?
Yeah. We're going up.
Okay. Instead of up and down,
Or
we're
we're
going
going
to
to
say
the
left
left.
and right.
Okay. To the
Going
left.
to the left. How many?
2.
2. You gotta go 1, 2 steps, right?
Right.
That's how many steps?
And
All
that's
right. Move your decimal over 2. 2
Okay.
steps to the
but
Left.
left.
right. And when you move the decimal, you get to be naughty because you start here at the decimal.
You wanna change your pen color? If you're writing, they're not seeing it yet.
No, I'm trying to change the color.
Oh, here. You can. You should be able to just do it by tapping on your pen.
I was doing. So you start at the decimal.
There we go.
1, 2. You got 2 butt cheeks. For every stair you take, you get to kick a butt cheek. Sometimes you have deformed butt cheeks. And so where's the decimal go? Right there where that butt cheek is. So our answer's right there.
Whichever direction you're going, I recommend putting an arrowhead on the end so it shows the direction that you're moving.
Yeah, I recommend you write down, you do that, which says what direction you move it and how many. Does that make sense?
So think of it while he's writing and setting this up. Let's think of why is this important? How would this be useful? Think about how we cook in the United States. Do you do any
Yeah, why
cooking
not?
at all?
Yeah.
Do a little bit of cooking? Let's say you're making rice and it says,
It's gone.
teaspoons, and all you have is a measuring cup for cups. Well, how many cups are you going to need to make your recipe? That kind of thing. So you'd be like, what? Without a table or a chart maybe in your cookbook that says how to convert from cups to teaspoons and all that, you wouldn't know. It's going to be very easy. People, when you look at recipes that are in the metric system, it is very easy to pick up any utensils you want to measure. And you can really just add the ingredients and just push it up. I wish I had some metric measuring devices in here to see how cool it is to cook in the metric system. It's pretty neat.
Okay, so on this problem, where are we starting?
You'll go to the.
Where are we starting?
Oh,
We're
the decimal.
starting with the 40.
No. What unit?
Wait,
oh, kilogram.
Kilo. And where are we ending?
And decigram.
Deci. So we're starting at kilo, and we're going to deci.
Oh, okay.
What direction are we going to travel?
Right.
We're going to go to the right. How many places?
4.
4. So I have my answer here. My 4874 is going to be there because that's what I have in my start. Start at the decimal. What direction am I going to go?
To the right 4.
To the right. So I go 1, 2, 3, 4.
So you add 2 zeros.
So then I just put the decimal right there, right?
Add 2 zeros.
You have to add zeros.
Good.
Okay, I did.
No, you have to put the 0 next to the 4, put 2 zeros, and then put the decimal after the last.
Why?
Because it's just doing the decimal place.
But why do I have to put zeros in there? Why can't I just put the decimal like that?
Because there has to show an actual number value.
Has to have a placeholder.
Yeah.
And that's true if you go left or right. Because if I write which number is the biggest?
The 5.7.
The middle one. Well, actually,
No, they're
2 and
actually
3 are
the
the
same.
same.
1 and 2 are the same.
1 and 2 are the same.
What was the question again, there?
Which one's bigger?
The 0.5.
I'm gonna say, I'm sorry, go ahead. I didn't mean to interrupt.
It's all really the same.
That's correct.
Because zeros don't really mean anything.
Yeah.
They're insignificant zeros.
Yeah.
So those are all the same. So if you move your decimal and you run out of numbers, put in zeros. Because you have to have your placeholders like you said. But I do that so you can see that they're all the same. Why don't we write the zeros? Because they don't matter. What about that number? Where's the decimal?
At the end.
Why at the end?
I forget why. Because it's a whole number.
That's correct. It's a whole number. And if it's a whole number, the decimal is insignificant. And where does insignificant people go?
At the end.
At the end of the line.
So if you don't see a decimal, it's always in the back. It's that invisible decimal point.
Always is, okay.
And because it's insignificant, we can have it or not have it.
It would be like,
Have it?
put on there,
Not
right
have
up
it.
there, $2. That $2, right?
Yeah.
What's another way of writing $2?
2.00.
There you go. Both of those mean $2.
Okay.
You understand?
Mm-hmm. So you ready to do some? I'm nice but also evil.
Okay.
This
Start
is going to
off,
be,
let's just do the
Oh, you
top
really
page.
do some?
well, there's 4 sides to it. But the nice part is the back side of the front is the answers to the front side. So you can do the problems and then flip it over and check yourself before you get to your homework problems.
Where's the homework problems?
Second page.
That second page is your problems.
This page right here?
No,
Right,
that's
this-
the answers
to this side.
to this side.
And this is the homework.
Yeah.
Yes.
So metric conversions A is what we want you to do right now here in class so that you can
Okay.
check yourself, make sure you understand, make sure you're getting the right answer. Metrics conversion B is your homework for tonight.
B and D.
and D.
B and C.
B and C. Okay.